Hello everyone, this is Mass EduStuff channel 01. Today I'm going to prove the mean and variance of the chi-square distribution. Recall that the chi-square distribution is an exponential distribution. That is to say, it's another version of gamma distribution. So the continuous random variable x has exponential distribution with parameter v. Okay, and the density function of chi-square distribution is given by f of x of v equals to 1 over 2 to the power of v over 2 gamma of v over 2 times x to the power of v over 2 minus 1 times e to the power of negative x over 2. The mean of the chi-square distribution is equals to v, and the variance of the chi-square distribution is equals to 2v. Okay, so now starting with the mean of chi-square distribution, I now have e of x to be equals to the integral 0 to infinity x f of x dx. Okay, by substituting the density function in e of x, I now have 0 to infinity, okay, x times 1 over, that is the density function there, 1 over 2 to the power of v over 2 gamma of v over 2, okay, times x raised to the power of v over 2 minus 1, okay, times e to the power of x over 2 dx. Okay, so this gives us the integral 0 to infinity. I multiply x and x, we now have x to the power of 1 plus v over 2 minus 1 times 1 over 2 to the power of v over 2 gamma of v over 2 times e to the power of negative x over 2 dx. And this line of equation gives us the integral 0 to infinity. Okay, by simplifying this, I now have x to the power of v by 2. Okay, I multiply it by the constant 1 all over 2 to the power of v over 2 gamma of v over 2 times e to the power of negative x over 2 dx. So if I bring out the constants, I will now have 1 over 2 to the power of v over 2 gamma of v over 2, then the integral 0 to infinity x to the power of v over 2 times e to the power of negative x over 2 dx. Recall that this is the proper definition of gamma function. So I will let t to be my new variable. So let t be equals to x over 2, that is the power on t on e, so that x is now equals to 2t. By differentiating x with respect to t, we now have dx be equals to 2 dt. So to substitute this in here, this value has to change. So the constant remain the way it is. I have 1 over 2 to the power of v over 2 gamma of v over 2, the integral 0 to infinity x to the power of v over 2 times e to the power of negative x over 2 dx. This is what I have here. Okay, so by substituting these new variables, I will now have the constant 1 over 2 to the power of v over 2 gamma of v over 2, okay, gamma of v over 2, the integral 0 to infinity. X will now change to 2t. So my x is 2t. I am substituting 2t for x. So 2t, okay, raised to the power of v over 2. So I will raise it to the power of v over 2 also. And then times e to the power of negative x over 2. I will now multiply a to the power of negative t instead of x over 2, because x over 2 is equals to t. Okay, so finally the x, I will now substitute it with 2 dt. So 2 dt. Okay, so I will now have to simplify it. The constant remain the way it is, 2 to the power of v over 2 gamma of v over 2, okay, the integral 0 to infinity 2 to the power of v over 2, okay, to the power of v over 2 dot t also to the power of v over 2, then e to the power of t negative t times 2 dt. So we have to bring out all the constants out. The first constant in, we have 2 to the power of v over 2. The second constant is 2. So bringing out this constant, I will now have 2 to the power of v over 2 times 2, okay, all over 2 to the power of v over 2 gamma of v over 2. I hope you're following. Then the integral 0 to infinity will now be t to the power of v over 2 dot e raised to the power of negative t dt, okay, which is a proper definition of gamma function. But it has defined as the integral 0 to infinity t to the power of v over 2 e to the power of negative t dt has been defined as the gamma of v over 2 plus 1, v over 2 plus 1. Therefore, gamma of v over 2 plus 1 can be simplified as v over 2 minus 1 plus 1 gamma of v over 2 minus 1 plus 1, okay, which is the same thing as v over 2 gamma of v over 2. Okay, so simplifying this further, this will now change to noting that 2 to the power of v over 2 will take care of 2 to the power of v over 2. So 2 to the power of v over 2 will cancel 2 to the power of v over 2, leaving us with, and so after cancellation we were left with the constant, 2 over gamma of v over 2, okay, integral 0 to infinity 3 to the power of v over 2 e to the power of negative t dt, okay, which changes to, the constant 2 to the power of over v all over gamma of v all over 2, okay, so times v over 2 gamma of v over 2. So it is clear that this also will take care of this, okay, 2 will take care of 2, leaving us with v, which shows that it has been proved that the mean